Hello and welcome. In this video, I'm going to be going through the concept of integration and differentiation and why they are opposite relationships of each other. So, first of all, let's start by defining what do we mean by opposite relationship of each other. Opposite relationship means that doing this will cancel the other. So let's say if I have an x squared, if I want to cancel the x squared, I will do square root. This says to me that square root and to the powering of 2 are opposite relationships because doing one thing undoes the other, or going from here to here is the reverse operation, obviously. So in this video, I'm gonna tell you why integration, which is basically something that deals with the area under the curve, is the opposite of differentiation, which is something that deals with the slope of the function. And by the way, I've done 2 videos going through the concepts of integration and differentiation. I will leave their links. Please click on them to understand why is integration the area under the graph and why is differentiation the slope. However, I'll go super quickly. For differentiation, let's say I want the area, or sorry, the slope of this curve at this point. So basically, it's the slope of the tangent on this point. So if I differentiate this curve, it's going to give me a function of the slope or a function of the gradient where I can put in any x, and it will give me the value of the gradient at that x. Okay, so this is differentiation. Why is it like that? Because differentiation, let's say this is f of x, so this curve over here is f of x. Okay, so the differentiation looks something like this: f of x plus delta x, where x plus delta x are and x and delta x are points on the graph. So minus f of x over delta x to the limit where delta x approaches 0. So we take 2 points. Let's say this is x and this point is x plus some small value delta x, so this is delta x. Okay, so the slope is basically the y of the first point, which is f of x plus delta x, minus the y of the first point, which is f of x, over the x of the second point minus the x of the first point. So x plus delta x minus x is basically equal to delta x. That's why over here we divided by delta x. So in the idea where this delta x becomes very small, infinitesimally small, this becomes the limit where x approaches 0, and this is basically the idea of differentiation of this curve. Okay, so this is differentiation. Let's talk about integration now. Let's say we want to find, let's say this is a and this over here is b. Let's erase this part. Yeah, integrating this function from a to b, f of x times dx, is basically finding the area under the curve from a to b. Okay, so this is integration and this is differentiation. Again, I will leave the videos for you to go and check in detail why is this, that, and that as well. So over here, let's think about this for a second. So let's say this over here is just some value of x. Okay, and this area, the area under the curve, I'm talking the area under the curve, is a function g of x. Why is it a function of x? Because the area under the curve depends on the value of x. If I take x at this point, then the area is here. If I take x as this point, then the area is a little larger. If I take x at, let's say, this point, so this is my x, the area is smaller. So the area depends on x. So the area is a function of x. Let's write this down, that the area is g of x, some function in terms of x. Okay, let's say I take another point over here, which is x plus dx. So this value over here is dx, and let's say that this dx is very, very, very small value that it approaches 0. Okay, this is this idea you will see a lot in calculus. So dx is approaching 0. So the area, this area under the curve until x plus dx is going to be this green area over here, all of this part, right? So this is the green area. Okay, so this green area is g of x plus dx. Okay, and the red area is g of x. Okay, let's say I want to take the difference between these two. So basically the difference between the green area minus the red area. So g of x plus dx minus g of x. What's that gonna give me? This is basically this whole green area minus the red area. So this is going to give me basically this part over here. This is the difference between the two areas, right? So this black area over here is the difference between the two areas. This is what I'm looking at. And on the limit where dx is very small, this area is gonna approach an area of a rectangle. So I'm gonna have an area of a rectangle. So this area of the rectangle is going to have what? Is going to have a length times a width. So what's its width? We know that its width is dx, okay? And what is its length? When dx is super, super, super small, its length is going to be the y point, okay, at x. So its length is going to be the y of x, which is basically evaluating this curve at x, or f of x. So the y value or the length is going to be f of x, and the width is going to be d of x, and multiplying those two together will give me the same area, right? So this is equal to that. And when I do a little bit of manipulation, I will divide both sides by dx. So dx here are going to cancel. So I'm just going to have this over here, okay? And we said we will throw in the limit as dx approaches 0. So what do we find over here? If you compare this whole left side, you will know that this is very, very similar to this. So it's basically, this left side is basically the differentiation of g of x. So this left side is g dash of x, right? So g dash of x is this side over here, right? So basically, g of x is the area function, okay? And when I differentiate the area function, so get the derivative of g dash of x, I end up with the original function. What does that mean? That means that when I have the area function, g of x, okay, when I differentiate it, I get g dash of x, which is the same as f of x. So let's erase this g of x. So differentiating the area function gives me the original function. And I know from the previous video that integrating the original function, so integrating the original function will give me the area function, right? So integrating f of x will give me g of x, and differentiating g of x will give me f of x. So this is how we say that differentiation and integration are opposite relationships. So if you do one, it cancels the other, okay? So this is the basic idea of why differentiation and integration are opposite relationships. This video is very helpful in understanding what you're doing, because lots of students ask me what's the relationship between the slope and the area. When you think about it in this way, you will see visualizing in your eyes that when you differentiate g of x, you get g dash of x, which we established that it was f of x, which is the original function. And I know that integrating the original function will give me the area function. Differentiating area function will give me the original function. Integrating the original function will give me the area function. This means that integration and differentiation are opposite relationships. I hope this video was helpful. Please don't forget to like, comment, and subscribe. If you have any questions or suggestions, don't feel shy to leave them down below. I will go through them and I will try my best to answer all your questions. Thank you so much for watching. Have a good day.